Okay, so this is going to be the video on section 2-5, complex numbers. First thing we want to remember is that when we talk about complex numbers, we're talking about square roots of negative numbers. And the most basic one is when we talk about I. And we need to remember that I represents the square root of -1. Then when we talk about I squared, we're going to say that that is -1. Okay? Then, if you know these two, what I and I squared are, then you should be able to figure out any other number. For example, I cubed. What would that equal? Well, rewrite it so that's in terms of I and I squared. That would be I squared times I, which is -1 times I. So we would just have -I. Okay, and then you could do this again for I to the 4th. We could say, well, that's I squared times I squared, which is really -1 times -1, so that's really 1. Okay? Now, first thing we want to do when we talk about complex numbers is we want to talk about simplifying them. Much like you've simplified square roots, you can simplify complex numbers. Okay? So for example, if I have the square root of -81, for any of these problems, one of the numbers I'm going to take out would be the square root of -1. And then if I take out the square root of -1, then I'm going to take out the square root of 81. And it just so happens that I already know what the square root of 81 is. That would be 9. And the square root of -1, if I look up here, is I. So this is I times 9. So we would say that that is 9I. Okay? Again, goal is to not have any negative numbers underneath the radical. So you should always factor out a -1. So let's talk about the square root of -32. First thing I want to do is factor out a -1. Then I have positive 32. So I want to think about factors of 32, and I would hope that one of them would be a perfect square. So we would say square root of 16 times the square root of 2. Okay, what is the square root of 16? That's 4. What is the square root of -1? That's I. So that piece is going to become 4I square root of 2. Okay, so that would be simplifying. Next thing you're going to do in this section, besides simplifying, would be adding and subtracting. Okay, so if I want to add or subtract, so let's say I had 5 plus I plus 6 minus 2I. Notice that this is not multiplying. I have an addition sign in between my two parentheses, so I'm adding them together. In order to do this, I'm just going to add the real parts, which are 5 and 6 together. And then I would add the imaginary parts, or the i's. So I'd have plus I minus 2I. So plus I minus 2I. And then I would simplify. Well, what's 5 plus 6? That's 11. Plus I minus 2I would be minus I. And that's as simplified as I can get that. You can't combine real numbers and imaginary numbers. Okay. Now what happens if instead of being written in terms of I, the things I want to add or subtract are written in terms of negative square roots? You're going to get more practice simplifying, and this was one of the things on your first test that people miss. So if you have a question, make sure you're asking on how to simplify these radicals. Okay? So here, we've got -2 plus the square root of -8 plus 5 minus the square root of -50. So again, I can just add -2 plus 5. And I know one part of my answer is going to be 3. Now I want to try to add my two imaginary parts, but I can't add the square root of negative 8 and the square root of negative 50 unless they have the same number underneath the radical. So let's start. We need to simplify square root of negative 8. Remember, you want to start with taking out a negative 1. Then think of factors of 8, where one of them is a perfect square. And I think you would think of square root of 4 and then square root of 2. Square root of 4 is 2. The square root of I is, or square root of negative 1, excuse me, is I. So we'd have 2I square root of 2. That's what negative 8 simplifies to be. Okay? Then let's talk about square root of negative 50. Maybe pause the video and see if you can go ahead and simplify that correctly. Remember, you always want to start out with negative 1. So I think you'd want to do negative 1 and then square root of 25, square root of 2. Square root of negative 1 is I. Keep getting ahead of myself. And the square root of 25 is 5. So we'd have 5I square roots of 2. And now that these both have a square root of 2 underneath the radical, I can go ahead and perform the addition or subtraction. And this one had a plus sign in front of it. So this 2I square root of 2 is going to be positive. Plus, this was a subtraction sign, so minus 5I square roots of 2. I actually just subtract 2I and minus 5I, so we should get negative 3I square roots of 2. So my final answer, because I had both my real 3 and then this imaginary piece, would be 3 minus 3I square roots of 2. Okay? All right, next thing we're going to talk about. We've got adding and subtracting. Next thing is going to be multiplying. So let's say I want to multiply the square root of negative 6 times the square root of negative 2. Okay? Out of each of these, I want to try to factor a negative 1. So I've written it so that I have taken out the negative 1. Okay? Now, what are the square roots of negative 1? Well, both of those should be I. Okay? Now, there's a property with radicals that says that if I have the same index, these are both square roots, then I can rewrite them underneath the same radical. So really, I'm going to have I squared times the square root of 12. And then I'm going to be able to simplify that. What can the square root of 12 get broken down into? Square root of 4 and the square root of 3. Right? 4 is a perfect square, so I know the square root of 4 is 2. So I really have 2 square roots of 3 is what square root of 12 is equivalent to. Now, I squared. If you need to, look back at our notes from the previous page. But I squared is actually negative 1. So this is really negative 2 square roots of 3. That simplifies to. Okay? Now, what happens if you wanted to do a FOIL problem? So it looked like that. Okay? You would just do basic FOIL. So 2 times 4 plus 2 times 3i minus I times 4. And then here's another minus 3i times I. Okay. So 2 times 4 is 8 plus 2 times 3i is 6i minus 4i, and this is minus 3i squared. Okay, go ahead and combine like terms. Here's 8. Right now I can't combine that with anything. Then I've got 6i minus 4i. Okay. Now, 3i squared. Well, what's I squared? Look back at your notes. It's actually negative 1. So negative 3 times negative 1 is actually positive 3. So really this is 11 plus 2i. Okay, dividing. When you're going to divide, you really multiply by the conjugate. Okay? So, let's say I've got 2 plus 3i divided by 4 minus 2i. So I'm going to go ahead and I want to multiply by the conjugate. So again, this should be something that you are familiar with. You would do this on your first test, and you've done this quite a bit. So instead of 4 minus 2i, I'm going to multiply by 4 plus 2i. Okay, here might be a good time for you to pause the video and see how you can do, because all I've done is turn this problem into 2 FOIL problems, one on the top and one on the bottom. So I would do 2 times 4, 2 times 2i. So go ahead and see if you can simplify this. Pause the video and see how you do. So I would have 2 times 4 is 8, 2 times 2i is 4i, and I would do 3i times 4, so I'd have plus 12i, and then 3i times 2i would be 6i squared. Then in my denominator, I would do FOIL again. 4 times 4 is 16. Then here I'm going to do 4 times the positive 2i, so plus 8i, minus negative 2 times 4, so minus 8i, and then this, minus 2. This should be a minus sign. There are a lot of you that are still missing that. Negative times positive, minus 4i squared. Now, go ahead and simplify that. Okay. So in the top, 8 plus 4i plus 12i. Here, is what I'm left with when I combine like terms. Now, these i's, squareds, I have 6i squared. So really, that's 6 times the negative 1. So that's going to turn into 8 minus 6 plus 16i. And then in my denominator, 16 minus 4i squared. This I squared is a negative 1, so really it's negative 4 times a negative 1, so that would be 16 plus 4. So I would have 2 plus 16i all over 20. Now, part of dealing with complex numbers is seeing if you are understanding that there should be a real and imaginary. So I need to break this into a real and imaginary part. And the first thing you need to notice is this can be simplified. Okay? So this would be 1, 8, and 10. Okay? And I guess the 8 and 10 are going to be able to be simplified even more. So, 1 over 10 is my real part, plus 8i divided by 10, and that one can be simplified even more. So my final answer for this should be 1/10 plus 4/5 I. Okay, so that's your video on complex numbers. We will be talking about how to use the quadratic formula with complex numbers. When you get a negative square root value, you can still simplify that to get an actual answer.